Good morning, afternoon, evening, wherever the world finds you right now. Welcome to the GLASSNET workshop on the quantitative modeling of sustainable development pathways. So my name's Tom Hurtle. I'm the PI for GLASSNET, and I'd like to share a few words about GLASSNET before turning it over to the session chair for today's workshop. So GLASSNET is funded by the National Science Foundation in the US, and it's a network of networks. So they've got a new program, ExcelNet, emphasizing the need to connect networks across disciplines and international boundaries. So there are 11 networks in GLASSNET, and each drawing on different disciplinary routes and maybe being based in different locations. The composition of the panel today reflects this diversity. GLASSNET focuses. Okay, go ahead and mute there. Oh, yeah, I'll mute. Whoops. Can you mute there, Holly? Thanks. So yeah, GLASSNET focuses, well, one of the areas of emphasis for GLASSNET is assisting early career researchers to gain international interdisciplinary experiences. And so if you want to learn more about that, you can email Holly or myself or go to glassnet.net. We focus specifically on attainment of the UN Sustainable Development Goals on a planet with limited land and water resources, and that's very much the theme of today's workshop. And the idea for this workshop grew out of our last biennial meeting at the University of Minnesota last fall. We're wrestling with the question of how to integrate these different approaches, different disciplines, address these sustainability challenges, trade-offs, and synergies, look at alternative future pathways. And in response, Hermann Lotze-Campen, today's chair, said, well, I can organize a workshop on that. We can do something on that. And so this was born, and we're very excited to have this group today. Let me turn it over to Professor Hermann Lotze-Campen. He's the co-chair of the Research Department on Climate Resilience at the Potsdam Institute for Climate Change Research, and he's a professor at the Humboldt University in Berlin. Hermann, over to you.
Yes, thanks, Tom, for the introduction. Welcome everyone here in the virtual room. We are very happy to have you here. Yeah, as Tom said, we have kind of a long-standing cooperation, and in this GLASSNET setting, we offer to give this seminar. Today, we have 2 hours of discussion time. We will have 2 presentations and then 3 short inputs by 3 discussants. And then we'll have hopefully plenty of time for discussions and questions and answers from you, from the audience. Yeah, I mean, GLASSNET is about global to local to global interactions on various dimensions of sustainability. And what we are doing at the Potsdam Institute and have done for quite a while, I mean, originally we had developed a strong integrated assessment capability, an integrated assessment modeling framework, as we call it. For many years, we have been engaged in many of the pathways and scenarios developed for and fed into the IPCC. So on climate impacts on multiple sectors, but also climate change mitigation, deep decarbonization, and yeah, maintaining or modeling pathways towards 2 degrees of warming or even 1.5 degrees of warming. And so we were originally strongly focused on climate change issues, and many of the pathways were fed into various of the recent IPCC reports. And then over time, it became clear, yes, but especially with ambitious climate change mitigation, there are potential side effects, trade-offs with other sustainability goals. So we try to expand our modeling capability beyond just emission accounting and like production, agricultural production, energy production, and macroeconomic development. And we added a number of, we try to embed certain processes in our models and also develop indicators so that we can say something about, in a quantitative sense, about the side effects of these ambitious mitigation scenarios. And this we now call sustainable development pathways. So pathways into the future, model-based, quantitative, rigorously quantitative scenarios on sustainable development and the interactions between these goals. And yeah, I mean, these global pathways, we have these global models with global coverage, but also spatial disaggregation in terms of global economic regions, and also finer spatial grids on, for example, land use allocation. And this is, of course, one side of the coin to come up with global scenarios, which can then be used for defining boundary conditions for national studies or even smaller scale studies. And then, of course, we can also go the other way around and picking up insights from specific regional technology studies or other exercises to then integrate that knowledge into the global pathway. So this is one way where I see GLASSNET very interesting, that we have colleagues from different disciplines working at different scales and try to connect these people in this network of networks, as Tom defined it or explained it in the beginning. So that was my introductory words, where we are coming from. And so today we have two presentations. The first, they are both from my team at PIC. So it's Isabelle Weindl, one of our senior global land use modelers in the group. Isabelle will present a new kind of a new generation of these sustainable development pathways from a recent large EU project. And then Benjamin Bodirsky, another senior modeler in our integrated assessment group, diving a bit deeper into the food and agricultural sector as a major element of a larger sustainability transition. And then we have with us as discussants, Becky Chapman-Kramer, Camille Renier-Capron, and Jean-Francois Soussana. And we'll have their discussant inputs after the presentations. And then we'll go into the discussion with the wider audience. That's what I wanted to say. We're very happy for all of you who are here. And I would now hand it over to Isabelle for the first presentation. Isabelle, please.
Thank you, Hermann, for the presentation and also the nice background. I will try to find my slides. Okay, can you see it?
Yeah.
Thank you. Yeah, today I will talk about sustainable development pathways, and not kind of just as a kind of general framework, but also regarding the implications for food and land systems in particular. And one important part will be how scenario analysis could reflect different societal perspectives on sustainable development. And this work is really part of a larger group effort realized within the SHAPE project, with several modeling teams contributing to the work, not only from Remind and MAGPIE and image modeling teams, which contributed a lot to the kind of land and food part, but also from other modeling teams like Message with partners from YASA, and also energy building specific model that also contributed to quantifications, also the scenarios. In addition, also social scientists contributed to the project, and we had a kind of large stakeholder process team. In the first part of the presentation, I would like to focus about what are the crucial components of sustainable futures for food and land systems. So how could they look like in a qualitative sense? And what does it mean for scenario design? And in the second part, I would like to talk about the quantification of the scenarios, and which is still also kind of work in progress. So we don't have published results yet, but are in the process of writing them up. Yeah, as you all know, food and land systems are really crucial for sustainable development. So they are kind of linked to many sustainable development goals and via many channels. If we focus on biodiversity alone, impacts are not only affecting SDG 14 and 15, but via direct impacts to many other SDGs, cascading through kind of almost all kind of the goals of the Agenda 2030. But there are still kind of main SDGs with a strong link to food and land systems, like zero hunger, but also linked via nutrition to good health and well-being, and the more kind of classical planetary integrity SDGs like life on land and climate action, but also via biomass demand and production. There's also a link to the energy system. So sustainable land and futures should reduce the trade-offs between two important clusters of SDGs, and they should strongly increase synergies with human health. And in addition, it will be very difficult to really improve only on the land and food system without looking at kind of other sectors. So it's also relevant and crucial to embed scenarios of land and food systems within whole economy pathways, because there are also linkages between, for example, mitigation efforts in the energy sector, compared to the food and land sector. So the main question is how to meet multiple sustainable development goals simultaneously. So sustainable development pathways are designed as so-called target-seeking scenarios. So not exploratory scenarios like the SSP, but really target-seeking scenarios that are kind of designed to make substantial progress towards the SDGs in 2030. But of course, development does not stop there. So sustainable development should be maintained after that, and the climate targets should be met at the end of the century. The target space is not only kind of defined by the climate target as in normal climate-only pathways, but really by several targets. And a first study or kind of analysis to achieve such a quantification of an SDP was done in 2021, where we also used the Remind-Magpie framework to go beyond kind of the narrative laid out in the SSP1 and defined additional sustainable development packages across many sectors of the whole economy, and analyzed how these additional sustainable development interventions could reduce trade-offs that arise from typical climate-only pathways. For example, one of the trade-offs that could be reduced was the increase in food prices that are normally seen under ambitious climate policy, and kind of also additional improvements could be made. So, and based on this study, we thought about how we could construct a scenario space with only kind of one possible way to reach the targets or improve kind of beyond a climate-focused pathway, but to really increase the option space and cover kind of multiple perspectives how sustainable development could be reached. And the idea was here to look at different dimensions across the whole human society, nature systems, and within these systems lay out different pathways how to improve several SDGs. So that was kind of the core of the scenario building and co-design process in SHAPE, to come up with a process to design multiple SDPs. And the first task within this process was to identify the relevant dimensions in which sustainable development should happen. So this would be kind of the main levers of that could realize interventions. And we did this together with social scientists, and also kind of developed, identified the dimensions together with stakeholders. And the second task was to create, so based on these 12 dimensions, to create really very different alternative sustainable development strategies for each of the dimensions. So one dimension was, for example, energy systems or the future of work. Another one was international governance or social systems, and also kind of the land and food system was one dimension, and the kind of approach towards nature. And then we had for kind of all the different dimensions, we had kind of different individual pathways, and the task was then to align the individual strategies of the dimensions to an overarching scenario narrative. And via this approach, we arrived at 3 different overarching narratives. But since the approach was following this modular approach, we could also construct more narratives. But yeah, our capacities were only kind of allowing for quantifying 3. And the next, or the last step before the actual modeling work was to translate the qualitative descriptions of the narratives into semi-qualitative information that could be then translated by modelers into quantitative parameterizations and assumptions within the models. And this was done not only for Riemann MAGPIE and image, but also for the 2 other models to allow for multi-model quantification of the SDPs. And the whole process was accompanied by an intensive stakeholder dialogue over the entire process. That means not only kind of in the beginning of the co-design process, but also kind of as we had preliminary results, there was also an interaction with stakeholders to evaluate the model outcomes. And from the beginning, the scenarios should reflect different perspectives, how to best pursue sustainable development. And these different perspectives were intended to reflect different regional, different societal, different economic perspectives on those pathways. So these are the main SDP narratives we derived from the SHAPE project. But as I said, the modular approach would also allow for creating more of these narratives. And so the first of the 3 main SDP narratives is called economy-driven innovation. And it focuses on technology, innovation, and efficiency as a main driver of progress towards sustainability, and strongly relies on continued economic growth and has focus on pricing as an important policy instrument. In contrast, the resilient communities as a second scenario features a post-growth economic development, especially in high-income countries. That means there's a kind of stabilization of economic development and a catch-up in in other regions. The main driver of change is lifestyle change and low material consumption patterns, and local solutions are preferred over kind of global action. And the focus is on solidarity, well-being, and equitable access to resources. And the third narrative, managing the global commons, combines many aspects of the above two narratives. So it both foresees also lifestyle change and technological innovation, but has a focus on strong international and national institutions and strong regulation as preferred policy instrument. So that's kind of was the part about how we constructed the narratives. And yeah, the second part is about kind of the first results. They are both kind of quantified by image and remind MAGPIE, because message and the other model did not implement the food and land aspects, but only the energy system and building sector narrative components. So the common features of the SHAPE SDP scenarios are that they share the same joint assumptions, such as population and education data, also demographics, which are important, for example, to estimate food intake. They are all kind of taken from SSP1. And all SDPs require functioning and stable governance and peace, which are strong assumptions. As part of the target seeking approach, there are kind of some targets which are kind of met by assumption. That means all SDPs meet the 1.5 target and only allow for a small and temporary overshoot. In addition, all SDPs intend to make substantial progress also towards the other SDGs, but as outlined before, they use very different strategies to do so. And here and also in the following results, the SDPs are compared with a trends continued SSP2 reference scenario, and they are compared to a kind of typical mitigation scenario, so an SSP2 1.5 scenario. So the first two slides, you see here that are the kind of the outcomes are not really kind of endogenous quantifications, but a part of the quantifications are already kind of prescribed by the assumptions. So on the left side, you see the different SDP scenarios. So on the top, the economy focused scenario, followed by the resilient communities and managing the global commons as a the third scenario. And here you see an excerpt of the modeling protocol. And on the right, you see the quantifications by Riemann and MAGPIE in this case. And regarding food intake and demand, the first SDP foresees transition towards sufficient calorie intake and a modest reduction in food waste. And regarding the dietary patterns, there is a decrease in livestock consumption, but it's realized by a substitution with animal-free meat and milk. So the dietary shift is more kind of realized by innovation than by really behavioral change. On the other hand, the other two, they have kind of dietary change towards healthy diets with a fast transition in the second scenario and a gradual transition until 2070 in the third scenario. And you also see this reflected in the results on the right-hand side, where you see that food intake decreases and the yellow and the green scenario. That means overweight is is mitigated, and in the blue one, only undernutrition is mitigated, but overweight continues to increase. And regarding food demand, which also includes food waste, you see here the results for the global average, but also for Europe and Africa. And here you see that all scenarios feature a kind of convergency of food demand over the 21st century. This is also reflected by agricultural demand. Here you see on the right-hand side results from the two models, so also from image. And in the first panel, you see the demand for non-energy crops, where kind of all SDPs display a reduction of crop demand until 2050, but only the SDP with a focus on supply side kind of has still a kind of very similar demand than the SSP2 based scenarios. And that's a very similar picture as for livestock demand, where we also see a strong reduction in the yellow and the green SDP scenarios, which are kind of which have a strong signal from the demand side from the dietary shifts. This is translated into efficiency. So again, on the left side, you see an excerpt of the modeling protocol, where the first scenario has a high increase in productivity and a high potential for bioenergy use. The last scenario lies in between, and the resilient communities have only stabilization of yields in efficient systems and a catch up in low productive systems. So that's the kind of information from the modeling protocol, and in Riemann MAGPIE, yields are simulated endogenously, but also kind of the endogenous model response shows a similar picture, where kind of lowest yields are simulated for the resilient community scenario. On the left-hand side, so crop demand per capita is defined as kind of all demand for food, feed, and also energy crops expressed per capita. And you see here also the signal coming from the energy sector via bioenergy demand, and also from the feed use, where you see a kind of similar material throughput in the case of the yellow and the green scenario, even though it's a climate mitigation scenario where also bioenergy use comes into the game, and it's very similar to an SSP2 reference scenario. So regarding land, we have, of course, the assumptions regarding diets, which are important to understand the land dynamics. But in addition, the three scenarios have kind of different foci of climate mitigation measures on the land side. So the first blue scenario focus on price-based policy instruments like carbon prices on emissions from land use change, and also carbon price incentivized afforestation. The second scenario focused on biodiversity and regulatory instruments. That means that there are kind of land protection schemes in place, and a preference for natural regrowth due to land abandonment from dietary change. But there's kind of no support for large afforestation projects. And again, the SDP MC, so managing the global commons, combines kind of two approaches, but also with a focus on biodiversity protection on managed landscapes, like, for example, having still extensive pastures. And as a result, we see that cropland area decreases in all three scenarios, but most in the resilient communities and least in the technology-oriented scenario. But all SDPs feature an increase in forest cover. But here again, the strategies differ. While the blue scenario is most strongly interested in fast carbon sequestration via plantations and afforestation projects, we see a focus on natural forest regrowth and the dietary change driven yellow scenario. Yeah, this is also reflected on the biodiversity intactness indicator, where we have highest increase for the scenarios with a higher focus on natural regrowth compared to the blue SDP, but all three of them perform better than a normal climate mitigation scenario in red, and of course better than a reference scenario. Yeah, and so that's my kind of, sorry. Could you please mute the microphone? Thank you. Yeah, that's the last result on greenhouse gas emissions, and in addition to the kind of previous assumptions, we also have mitigation of non-CO2 greenhouse gas emissions in all SDPs and peatland protection and restoration. And kind of the main results is that, but of course, all SDPs have to meet the climate targets, so they reduce emissions from all sources. But again, the foci differ. That means that the blue scenario with a kind of more focus on afforestation and on pricing and less on dietary changes contributes more via negative emissions from CO2 on the land use side. And the other two scenarios where the dietary change part is more strongly represented, they reduce the non-CO2 emissions more strongly. Yeah, so yeah, we see that the three SDPs explore very different pathways, how to meet the climate targets and how to improve progress towards the SDGs. And if we just follow current trends, we are not on track for either of the targets. The narratives on which these quantifications are based are derived from a co-design process and represent different perspectives on sustainable development, also regarding kind of regional perspectives. All SDPs realize the 1.5 target and improve regarding many other indicators beyond the kind of typical climate-only mitigation scenarios, which was also a result by the first SDP paper from 2021, and also a main result of the shape overview paper from Circle et al., which is currently submitted. But the underlying strategies differ quite strongly. So the blue technology-focused scenario has a strong focus on price-based instruments and more on the supply and land CO2 emissions from land use change and not so much on diets. And the resilient community scenario puts a lot of emphasis on low demand and behavioral change, while the SDP MC is a mix of kind of both approaches and looks at systemic synergies with a focus on regulation. And via using a multi-model approach, we intend to increase the robustness of the assessment and have a better grip on synergies and trade-offs of the different strategies, and but also regarding the uncertainties. Yeah, thank you.
Thank you very much, Isabelle. So this was an overview of some work in progress, our latest work on these different types of SDPs, also with this co-design setting. Thank you very much. And we are now proceeding with Benny on the FSEC-related pathways. Benny, please.
Can you see my screen in full mode?
Yes.
Okay. So I would like to present to you today a study that was developed in the process of the Food System Economics Commission. Hermann had a very active part in this process, and the study that I'm presenting is one, are the scenarios that underlie this the report of the Food System Economics Commission. Okay, and the preprint is available online, so you can download it, and I think it was also circulated before this. Let's start with a question. Can you imagine a global food system which is consistent with 1.5 degree? So what are the ingredients needed? Well, first you need to stop deforestation, you need to re-wet our peatlands, you need to reduce livestock consumption and feed the remaining animals more sustainably, you need to fertilize more efficiently, you need to build up the soil organic carbon, and eventually even reforest some of the forests that were cut down. But actually, all of this is not even enough, because for 1.5 degree, of course, all sectors need to contribute. And all sectors are to some degree also, again, dependent on the food system. So the energy system wants to have bioenergy. The transport sector wants to have biofuels. The construction sector wants to have timber for buildings to replace cement and steel. And the industry sector wants to have bio-based material. So actually, a global food system consistent with 1.5 degree also needs to provide all of these services to the other sectors. Now, you can imagine that such a world is quite extreme, and you may wonder whether this might not have adverse side effects. So you can imagine if we restrict all of the land, do we still have enough land to produce the food that we need for a growing world population? And even if we manage to produce all of this food on the remaining area, doesn't that mean we need to intensify this land tremendously? And this, again, can cause other environmental problems by nitrogen surpluses, by water withdrawals, or by monocultures. And if we produce all the biofuel, doesn't that increase the food prices and then create a trade-off with food security? So actually, we have to be very careful that ambitious mitigation food system could create dangerous adverse side effects. And therefore, any climate change mitigation alone is not enough, but you need to have a food system transformation that has a broader set of goals. And in the Food System Economics Commission, we came up with 3 overarching goals: global health, including both the absence of hunger, but also of overnutrition and diet-related health risks. Environmental sustainability, going beyond the 1.5 degree target, but encompassing all planetary boundaries. And social inclusion, meaning that a lot of people receive their livelihoods from agriculture, and at the same time, food is also a big expense for people, so it's directly connected to poverty. So to understand how such a world looks like is very important. So we need a vision for a desirable food system. Why? Well, we need to make decisions, political decisions, and for that we need strategies and we need some foresight, and we need to set priorities. What are the important measures? What have to come first? But visions are also important for every individual of us because they motivate us, they give us hope, and they help us to build expectations and to also plan our own careers or our investment decisions based on what we expect the future may look like and hopefully could look like. But who can come up with such visions? Right? There was the former chancellor of Austria who said, like, those who have visions, they should go to the doctors, or they should go and see the doctor. And indeed, at the moment, I have the impression that politics doesn't want to come up with the vision. So maybe us, the doctors, are maybe the right persons to come up, as long as politics doesn't want to do it. So we thought, okay, let's come up with a vision, but a vision should not be wishful thinking, right? So it should be science-based. So it has to be plausible. It has to be well thought through. And this rapidly exceeds the capacity of our minds. So at least I cannot do it in my head. What we need are actually tools that help us with that, and that can be computer models. I don't want to say that computer models are more smart than humans, or machines are more smart than humans. No, but mathematical modeling can help us to structure our thoughts. And that's quite important. As we write down all the things in equations, we can formalize it. And the other thing is mathematical models are a great tool for collaboration. So a lot of people can work at the same time on this vision. And for example, in this study, more than 30 people were involved, looking at different parts of the food system through the modeling. So in the center of our analysis is the land and food system model MAGPIE. It's a global model, yet with national or subnational resolution. And you can imagine it starts off from the food demand. So it looks at what are people eating today and how will this change in the future when they become richer or when the population grows. Then we check basically on country level, what is the food demand? We also look at the livestock sector. So what do animals eat and how does this change in the future when the livestock sector is becoming intensified? And then we check, okay, how can this food and this feed be produced globally? So where are attractive production areas? Where can we intensify? Where can we expand the land? And then also, what are the environmental consequences of this? So if we expand cropland, we cut down forests, we lose biodiversity, but also if we intensify land, we get nitrogen surpluses, we get N2O emissions, we get monocultures, we eventually also lose biodiversity. Okay, so the MAGPIE land system model is really core and for this analysis. And as I said, it works on a spatial resolution, either on the country level, on the world region level, or even on a high 0.5 degree resolution globally. So the projections that we are doing are on a high resolution. Yet to answer the questions that I opened up in the beginning with the sustainable food system transformation, our food system model is not enough. So we basically, for this study, we embedded the MAGPIE land system model in an even broader framework of models. This is called the PIAM framework, the Potsdam Integrated Assessment Modeling Framework, and it even includes here a model from outside of the PIAM framework, which is a dietary health model from Marco Springmann to estimate for each diet that we simulate what are the health risks connected to it and how does mortality change when people eat differently. Then the Remind Macroeconomy and Energy System model. This is used to estimate the interaction of the food system with other sectors of the economy. And together, the land system model and the energy system model provide greenhouse gas emissions, which go into a climate model. And then we can see what is the global warming that can be expected based on the temperature, the greenhouse gas scenarios that we put in. We get using a simplified climate model matrix C, we get the warming. We then put this to select, or take this to select a high resolution climate scenario from the EasyMap database. We take temperature, precipitation, feed this into a biophysical model that provides the inputs with regards to yields, carbon densities, water requirements, and so on for MAGPIE. Yeah, and finally, we have a poverty model included to see if people spend more on food, how does this change the poverty levels? And all of this framework then can be used to come up with 15 high-level indicators of the food system covering health, environment, and inclusion. And I now show you some results. First, I now focus on the global results because the time is limited. And first, I show now the business as usual scenario and the trends that we see until the year 2050. So let's start with health. We can see first that in the business as usual scenario, because of income growth, underweight, hunger is slightly declining. Obesity, however, is strongly increasing. And if you saw the news last week, we surpassed now 1 billion people of obese people globally. So our projection, at least for the moment, is not so bad. Well, it is bad, depending on what's good and bad here. It is accurate, but bad. And with regard to premature mortality, we can also see it's strongly rising in the future. So these are health risks connected, for example, to diabetes, to cardiovascular diseases that come from diets. Next, let's look on the environment. What can we see there? Well, in the business as usual scenario, biodiversity is slightly deteriorating, both on in natural ecosystems, but also on croplands. We see that nitrogen surpluses further increase with growing production globally. We can see that greenhouse gas emissions stay high. They don't further increase, mostly because deforestation fades out. But we also have CH4 and N2O emissions, which are continuously rising. So in total, we have roughly constant emissions, and this, because they are positive emissions, leads to accumulation of greenhouse gases in the atmosphere, and we get a global surface warming that exceeds 2 degrees already in the year 2050. And lastly, let's look on the inclusion indicators that we simulate. So we see that because of income growth, poverty is declining. It's not declining to 0 as targeted in the SDP scenario, but it's declining steadily. What's also declining is agricultural employment. This is a continuation of the structural change that we already observed today. Labor productivity is rising. Food demand is not rising so much. So as a consequence, employment falls. And agricultural wages, on the other hand, increase. Expenditure for agricultural products also increase, but mostly because people become richer and eat more diverse food. Okay, so in total, you can say, well, sometimes it requires an acceleration of the development. So the trend goes into the direction that is intended, but far too slow. Sometimes it really requires a strong trend reversal, especially with the environmental indicators. And in general, our food system is not really on track. So we can say business as usual is not really an option. So what can we do to improve? And for this, we looked at 28 measures that could make our food system more sustainable in 5 intervention areas. With respect to diets, we looked at different dietary changes, eating less meat, eating more legumes, eating more fruits and vegetables, reducing food waste, reducing hunger. For the biosphere, we looked at how can we protect the biosphere by, for example, protecting biodiverse lands, by protecting water withdrawals. With regard to livelihoods, we checked what would happen if we increase the wages, or if we liberalize trade, or if we reduce the capital intensity to promote employment. With regard to agricultural management, we looked at soil carbon management, nitrogen use efficiency improvement, manure management, more circular manure management, and several other measures. And finally, cross-sector, these are these interactions with other sectors, including, for example, biofuels or the production of bioplastic. And I will now pick out just a few examples of these measures and show you a bit more in detail what they entail. So this measure here increases the food consumption of legumes, beans, peas, groundnuts, and soy, and replaces staple crops like grains and roots. And we parameterized the quantity of this legume intake based on the Planetary Health Diet recommendation from the GLASSNET Commission. So what do we see? First of all, the dietary health improves. Premature mortality declines by 25 million life years per year, which is a lot. We also see that crop rotations on the fields become more diverse because legumes are eaten more and then can also be integrated into the crop rotations, and they are very good for crop rotations. We also see that industrial nitrogen fertilizer drops because pulses can fix their own nitrogen. And because they have a higher nitrogen use efficiency, the nitrogen surplus also drops by 2 million tons. And finally, we see a negative effect as well. The production costs increase because legumes are more expensive than grains. And therefore, expenditure for agricultural products increases. And in line with that, also poverty increases. Another measure that we simulated is what happens if people in agriculture are better paid. So we increased a minimum wage of we included a minimum wage of $3 per hour by the year 2050. This is more like a modeling assumption, right? So most people are not employees in agriculture, but we basically simulated as if they were employees and could therefore receive increasing wage for their labor force. And what we saw, of course, is that wages increase, so that's positive. But what we also observe is that because it's a minimum wage globally, we see a shift of food production from the global south to the global north. And because many of the biodiversity hotspots are located in the global south, biodiversity actually improves. But again, there are downsides to it. The minimum wage really strongly increases food prices. And because we are shifting production from the global north to the global north, with much higher labor productivity, employment is strongly reduced. Another option, biosphere protection, where we protect roughly 30% of the global land, the most biodiverse areas. So biodiversity on these areas improves, and that's evident, but we also see negative leakage effects. So those areas which are not protected, especially those located close to existing croplands, they strongly see a decline in biodiversity. Also, we see that the remaining cropland area is strongly intensified, and this both leads to higher adoption of monocultures and to higher nitrogen surpluses. We see that CO2 emissions are reduced because mostly the biodiverse forests are protected. But we also see that because of the increasing land scarcity, the food prices rise and more people end up in poverty. Next measure is livestock management. Here we intensified the ruminant systems in the global south mostly. What we see is a really strong reduction in methane emissions, which even can lead to, like as a single measure, to a high warming impact where warming decreases by 0.04 degrees by 2050. So that's actually a lot. But we see that much more people are employed in agriculture because you need to produce a lot of concentrate feed instead of putting the cows just on the pasture. But at the same time, we see again shorter crop rotations, and we see increasing land scarcity, increasing production costs. So producing them with concentrates is also more expensive than putting them just out on the pasture. So we actually see an increase of people living in poverty. And finally, cross-sectoral measure the energy transformation. Here, basically, we just produce more biofuels for the energy system. We see that global warming is strongly declining, also because the energy system decarbonizes, but our emissions in the land system go up because of the biofuel production. We see a lot of new employment in the agricultural sector for producing the bioenergy, but we also see negative side effects again. So bioenergy requires fertilization, and they occupy also large land areas. So as you can see, all of the measures that I presented have good and bad sides. So usually green and red areas. And this is not just these 5 measures that I presented, but this was really the case for all 28 measures that we simulated. So here in this overview graph, you don't have to look into it in detail. What you can see is basically all the 28 measures that we simulated and all the 15 indicators. I just want to highlight here the colors. So green means good, red means bad, white is no major change. And you can see that all measures actually have green and red areas at the same time. So there's not a single measure which only has benefits, which also explains why it hasn't been implemented so far, maybe. But, and now comes the positive thing, if we combine all of these measures, if we bundle them, then actually many of the negative side effects cancel out. And this is the last scenario here at the very bottom. And there you can see actually all indicators improve except for one. And this indicator is agricultural employment. So we see a really strong decline of agricultural employment, halving almost from, or more than halving from the situation in 2020. And this, of course, means that these people formerly employed in agriculture have to be absorbed in other sectors. So new employment opportunities have to be created for them. Looking at this figure again, and now we are adding the sustainable development pathway, the food system transformation pathway, we can see actually that trends improve for almost all indicators except for employment. And maybe just highlighting some points here. So global surface warming, here we really managed to stay at 1.5 degrees. Really tiny overshoot, 1.53 or something like that. But we have a very good chance of staying with 1.5 degrees, more than 50% chance, or 50% chance roughly. We also see, for example, for nitrogen surplus, we managed to decrease them strongly, but still, just to highlight, this is still above the planetary boundary. So getting below the planetary boundary for nitrogen is really one of the most difficult tasks within the planetary boundaries, so almost impossible. And last point is that we see, as I said, much lower employment, but at the same time, much higher wages. So the remaining people employed in agriculture are actually much better off. Coming to the conclusions. First of all, like a scenario or a future where we just do mitigation is not really sufficient. A desirable food system needs to be healthy, sustainable, and inclusive. And we have to keep that always in mind when we think about it. And we need very concrete visions of such sustainable food systems because they motivate us, but also because they help us to come up with political strategies. All measures have co-benefits and trade-offs, and this also explains why the system is so inert. But if we bundle them, we can actually create win-win situations. This could eventually facilitate change if we manage to put these bundles together. And the good news, at least in principle, a sustainable food system is possible. Thank you.
Yeah, thanks very much, Benny. So I guess we had a lot of input now and hopefully enough food for thought. We right away move into our 3 discussions. And first we have Becky Chaplin-Kramer with us. And Becky, I hope you can give us a perspective on this from the Natural Capital Project, the NatCap perspective. And we are looking forward to that. Becky, the floor is yours.
Thank you. Thank you so much. And thank you to our speakers. That was great. Yes, I'm Becky Chaplin-Kramer. I'm the global lead scientist for biodiversity at World Wildlife Fund now, but I have spent most of my career with the Natural Capital Project, of which WWF is a member. I'm a landscape ecologist and socioecological systems scientist, spent a lot of time with NatCap and even before modeling ecosystem services. And now working on embedding the diverse values of nature into our conservation work at WWF, where we're working to create a future where people and nature can thrive, like all of us here. So these types of scenario modeling approaches, I think, are really fundamental to our work at WWF, because conservation through protected areas and restoration projects alone represents only a small fraction of the solution to really to these global sustainability challenges. And if we're going to meet our conservation goals to halt extinctions and the loss of all remaining high integrity ecosystems, we have to address the drivers of this loss. So the modeling work that you presented here, Isabelle and Benny, really help clarify how those drivers differently play out across the world and across different sectors, and illuminate the potential policy mechanisms that could put us on better pathways to more sustainable development. And Benny, your title reminded me of a Thomas Edison quote I just heard for the first time yesterday, but you probably have all heard, "There's a better way to do it, find it." So I think that's what we're all trying to do here. It seems like deceptively simple and it's actually really complex, but that is what we're striving for. And this work is so impressive and useful already, but I think there's still more we can do to make it even better. So I'm going to quickly highlight the 3 frontiers that I see for where to take this next to make it easier to find those better pathways to sustainable development, by first integrating more sophisticated Earth observations into modeling, accounting for ecosystem services that are supporting our productive systems, and broadening the diversity of values that we're able to represent. So on the first one, integrating Earth observations, better Earth observations into modeling, I think this really can add some of the heterogeneity that's often missing, but can make a huge difference overall. So there's a great paper I'll drop into the chat that shows under-yielding areas, areas that we basically shouldn't be producing on, that you're actually losing money on, account for 23 million acres across the US Midwest. That's 23% of the total corn and soy acreage, which is huge if you think about, the trade-offs that you were showing, Benny. This is where a lot of room for win-wins exist, even within that individual sector. We can mitigate a lot of the apparent trade-offs that Benny showed within that sector, improving biodiversity and ecosystem services without losing any production if we're just smarter about where we produce. The next frontier, thinking about ecosystem services supporting this work. Even though I think I am familiar with some work from this lab, or maybe it was Alex Pop's lab that has worked on pollination and endogenizing pollination into the modeling of the yields, which is huge. That would be, like, in my own opinion, a huge advance. I have worked a lot on pollination, but there's a lot of others to consider as well, thinking about sediment delivery and soil formation, of course, water provision and the seasonal water availability, but also, things we don't often think about, like precipitation sheds. So far away ecosystems can actually provide, a lot of moisture to especially rain-fed agriculture that it relies on. And in a recent paper, we actually showed that vegetation mediated moisture recycling. So the water that comes from ecosystems evapotranspiring provides 65% of the precipitation on the areas that we have defined as the most critical for ecosystem services. 65% of that comes from land and not oceans. I think a lot of people think the water cycle all comes from the ocean. So the vast majority is coming from ecosystems. And the largest volumes is coming from working lands. So populated rangelands and forests, not remote wilderness. So to me, this really shows the intimate connections between working lands and natural lands, and we have to consider the interactions between them. And we have another paper that Tom and others here were on that's still in preprint, but I'll also share that because it's really calling for this kind of modeling and making the connections to show those interdependencies, to say, you've made beautiful scenarios. We now actually have to represent the feedbacks between ecosystems and how this is going to long-term affect our ability to, sustainably continue to produce food. And yes, and I'll drop that into the chat as well. I have a bunch of links to share with you in just a moment. And then the last piece of thinking about multiple values, you've already showed so many, and it's so impressive, like 28, different indicators. I hate to say you need to diversify, but I do think that a lot of these are, what we call instrumental values. And I'm pulling on the best values assessment here that I, spent a lot of time working on and really changed the way that I approach and think about representing values. Instrumental values often crowd out relational values that actually might be the piece that tilts the scales in our favor. When people respond to things, it's often the way that they feel and not just the things that make dollars and cents. And so we think about, in this context, aesthetic values of the countryside, our sense of place, our way of life, our identity. And I'm so glad to see the resilient community scenario in the SHAPE work. I think that hits on many of those values, which is awesome. So now we need our modeling frameworks to capture some of these values, to assess the outcomes beyond instrumental. So how do we link instrumental modeling outcomes that are easier to model to relational values, like considering the declines in agricultural employment that you showed, Benny? Can we assess how that would impact sense of place, community cohesion, and identity? And so I think, there's just so much already exciting about what's going on here, but I think these could really help us speak to broader audiences, build the coalitions that we need to move forward on the sustainable development pathways. And I'm just excited for this community to help tackle these challenges together. Thank you.
Yeah, thanks a lot, Becky. Very, very useful. And yes, of course, we are aware of things. Many more things can be done, but it's so great, to be connected here in GLASSNET and via different channels, IPBES and so on. So the nice thing is we can keep working on this further, right? And look at different processes and feedbacks. I mean, these internal feedbacks are really important. Yeah, I'll come back to that in the end. So thank you for that. And please, share some of the links you had. I hope, Tom, we will collect the thoughts and the chat to kind of summarize later, I guess. And we now turn to our second discussant, Camille Cambon from the Global Land Program. So Camille, please.
Thanks for having me here. I'm also going to share one slide while I talk. Sorry, bear with me one moment. There we are. Yes, so I'm going to jump in and bring some perspective from a land use perspective, and with particular focus on justice and equity concerns that can arise when certain assumptions are not acknowledged. So while I feel that the kind of research that we saw today is absolutely necessary, there are very strong geographical implications because the results of these kinds of proposals ultimately play out through land use change. So this carries risks for several dimensions of environmental justice because the world is not empty, tenure is not always secure, people are not always integrated into globalized markets for selling or purchasing food. And sometimes when land is seen as marginal or as an opportunity for increasing yields through agricultural modernization, it can also displace marginalized or vulnerable communities who rely directly on the land for their nutrition and well-being through subsistence-oriented practices, for example, and who may have other sustainability needs. So indeed, we saw earlier that there are many different ways to, or pathways to sustainability. And so the task then is to be able to discern on what land each of them are appropriate and just, and how we might restrict them or put them in check when they are inappropriate or unjust. So the first point that I really want to drive home is that the global efficiency framing can sometimes be blind to the needs of smaller scales and can therefore lead to inequitable solutions. So when we talk about sustainability within a land use modeling community, we often run into this efficiency framing that sort of assumes that the current system is wasteful and perhaps poorly managed, but ultimately many components of it are necessary. And so this kind of thinking is probably more in line with the economy-driven innovation pathway described earlier by Dr. Weindl. But it isn't necessarily limited just to the economy. It's also translated into the realms of environmental management and land use planning. So for example, when we think about biodiversity conservation, often proposals seek to capture areas with the highest biodiversity value in a network of protected areas that covers the smallest amount of land so it doesn't compete with agriculture. But this can sometimes lead to inequitable burden sharing results. So to illustrate this, a paper that I published last year, I took a handful of leading socioeconomic scenarios as well as several conservation prioritization templates, and I contrasted these with areas where nature was contrasted certain areas where nature was projected or recommended to expand, representing nature restoration opportunities, with a likely distribution of people who have insecure tenure and depend directly on the landscape for at least some of their nutrition. And the results showed that globally efficient pathways may have a disproportionate impact on the most vulnerable communities. And so global planners really need to take equity considerations into account in their modeling frameworks and be more explicit about their assumptions around burden sharing. So the second point that I want to make is that it is possible to integrate differentiated futures into a single modeling framework. So this forces us to be explicit about which sustainability framings we adopt and the assumptions associated with these framings, in what context they are appropriate, pardon me, and also ways of restricting them when they are inappropriate. So I touch on this in another paper, which was just recently accepted by One Earth, which should be published in May, hopefully. Where I model a scenario in which business as usual demands for crops and livestock are pursued along demands for regional biodiversity intactness. But then I also introduce a mechanism which aims to protect land-dependent communities from land grabbing. So what this looks like in the model is that in certain types of land systems or in certain areas are restricted for conversion in order to meet the regional or global goals. For areas where certain land systems are important for land-dependent communities. And actually what we see is that there's no trade-off. Land grabbing is totally unnecessary for meeting our global market demands for food commodities or for promoting landscape biodiversity. So the intention within this paper is not to essentialize smallholders or assume away certain development objectives, but it is to recognize, first of all, the essential role of these localized and often informal food systems for feeding much of the developing world. Second of all, the incredible amount of injustice that has been caused historically from top-down agricultural modernization and land reformation campaigns. And thirdly, the explicit demands and values advertised by the food sovereignty movement and other peasant land rights movement for equitable and democratic control over local land resources. So in this sense, we assume, based on literature and the values of the food sovereignty movement, that multifunctional mosaics, which have a certain amount of natural habitat interspersed with agricultural systems, will be promoted in certain areas, in these areas. But also the idea is that we can't know exactly. This is a limitation of our modeling framework because it needs to be driven by democratic process. So instead we try and make space for it in our model for this awareness and also try to avoid doing harm. So in addition to all of that, while there is no trade-off between anti-land grabbing and other food commodity production or the promotion of biodiversity, in certain regions, there were trade-offs between biodiversity and livestock and sometimes even crops. We were following an SSP2 pathway. So I think it would have been really interesting to have been able to integrate Bodirsky et al.'s food system model, as this might have been able to reduce these spatial trade-offs. So yeah, in a sense, we were already taking a small step towards trying to integrate multiple futures. So using the words or the framework terms from earlier, we were in a sense, trying to include the economy-driven pathway in terms of food production and trade, while also leaving space for resilient communities in terms of respecting the land rights of vulnerable communities. So this brings me to my third and final point. When it comes to projecting diverse futures, contemporary modeling frameworks face some serious constraints. So for instance, global economic models function by connecting supply with projected demand, often using price indicators, but this can overlook the nutritional needs of those who have no purchasing power, for example. And it can also view subsistence-oriented landscapes as marginal and therefore ripe for improvement. So I'm particularly wary of one-sided model construction because it can lend authority to hegemonic discourses around land, while making invisible the perspectives of marginalized communities on the ground, or even making the communities themselves invisible. So one example of this is a spatial accounting mechanism used to support a Congolese RED program, which functioned or was found to function to legitimate private actor control over what were seen as empty spaces on the map, while framing the livelihood practices of homogeneous local populations as destructive agents. And I think like this kind of process is quite common from in top-down modeling frameworks. So this can obscure struggles over land, leading to multiple forms of injustice and displacement, and enable commodity model cultures to gain a foothold at the expense of locally important land systems. So what we need then are models that can check the assumptions of our sustainability pathways and restrict these pathways to areas where they're suitable and appropriate, while also checking them where in areas where other pathways might be more appropriate. And it is because of this that I'm particularly interested to see where the land use modeling community might go with the scenarios that came out of the SHAPE initiative. I think this is quite exciting to have different scenarios to work with that kind of make explicit some of these different assumptions and value systems. So it'd be wonderful to see if these three pathways could be combined in a way where each are promoted, yes, at the appropriate scale and geography, and perhaps even with some feedbacks in between them. Would be quite interesting. But as Dr. Chaplin-Kramer said earlier, we also need models that are explicit about the way we perceive the drivers of unsustainability, and find ways to break down and phase out these processes in our scenario pathways. So if we solely focus on the build up of sustainability indicators, there will be less and less space available for meeting our different needs, and this can automatically shuffle us into an efficiency framing. But if the drivers of unsustainability are addressed, then we also open up space for fundamentally different processes which are more capable of meeting our diverse needs. So to wrap my part up, I just wanted to thank the presenters again. Both provided very valuable insights in a very important field. And I think that, yeah, exploring transformation pathways is an absolutely necessary endeavor, given the many interacting challenges that we have, that we face. So yeah, I really encourage greater research to unpack the interactions in between different proposals and the associated land use change dynamics. And I look forward to seeing what modeling results come from these. I apologize if I spoke a bit fast. I'm not sure what time it is now, but I will stop sharing my slide, and thanks again for having me here.
Yeah, thank you very much. Thanks, Camille. Very, very good. I mean, now we heard about, well, even more challenges, but also opportunities, right? More diversity in terms of the ecosystem service indicators from Becky, more disaggregation and diversity on the justice side. I mean, both elements which are absolutely important. And I think we have only started to, you know, to explore and putting the basics into our models here. So I hope Benny and Isabelle get prepared for some constructive responses. But first we turn to Jean-Francois Soussana to give us a bit of a perspective from the policy perspective. Another, of course, important dimension about, you know, how to do all these things. I mean, how we can talk about pathways a long time, but how do we actually do this? So Jean-Francois, we are curious to hear what you have to put into this.
Thank you, Herman. My name is Jean-Francois Soussana. I'm a senior scientist at INRAE, and I'm also currently the Vice President for International Policy. So I guess this is a reason why I'm a bit exposed to policies. I would also like to thank the presenters. This is really an impressive work, and as we will see, it's highly relevant to the policy issues. And I would also like to thank the discussants. They brought very convincing perspectives on ecosystem services and justice, and I do well understand how difficult this is to include in the models right now, but I think it's very important for the future. So actually, I would just like to say a few words about the policy context first, and second, on possible ways of improving the modeling we do and the narratives, the scenarios, and so on. So the policy context first is that we do realize after the Global Sustainable Development Report published in 2023 by the UN that it is unlikely that any of the SDGs will be achieved by 2030. Actually, we are regressing in some cases, we're not progressing. And therefore, the perspective is both how could we reach the SDGs later, possibly by 2050, and equally, is it possible to rethink some of the SDG targets? And this will come into the UN agenda because there will be some rethink about SDGs and SDG targets. Unfortunately, we are also very likely to overshoot compared to the 1.5 degrees Celsius target from the Paris Agreement. And here again, this means we may need to explore, this has been done obviously quite a lot in the past, the 2 degrees Celsius. The food systems, they are really in a central place compared to the acceleration of progress towards SDGs, because this is one of the 6 entry points which was defined by the UN for accelerating SDGs. There is a major international effort led by the UN for food system transformation with close to 150 countries that have already are already working on their national pathways for food system transformation. And at COP28, we heard about the possible convergence between reaching the Paris Agreement, so through for carbon neutrality and food system transformation. This is now on the agenda, trying to have a convergence here. And as you know, convergence between climate change and biodiversity is also to some extent progressing. So food systems are in a central place for the SDGs. They are also quite clearly in a central place when we talk about the transgressions of 6 planetary boundaries. You know, obviously, that food systems contribute to 30% of the global greenhouse gas emissions, possibly up to 80% of biodiversity loss, up to 80% of tropical deforestation and so on, and wetland loss, and 70% for freshwater abstraction, possibly that is a range between 50 and 70%. And it is also a major role for the imbalance in the nitrogen cycle. So we have really this big challenge. And what you have shown with the sustainable development pathways and the target-seeking scenarios is very useful. And I much appreciate this change compared to the earlier modeling, which was based mostly on economics. We have there the assumption that business as usual is not an option and that the costs are not going to prevent changes. However, I guess that in the modeling, we have to realize that not all options have the same costs. So we can assume faster adoption of the cost of the options which have lower costs. There is another aspect which I think you are capturing well, which is about the trade-offs and synergies across responses. This means that some options, like the large-scale deployment of bioenergy and BECT, they are creating large negative side effects for food security and biodiversity. So we may need to prescribe upper boundaries for those options. Otherwise, we are not going towards the SDGs. So coming to maybe some limitations of what I can understand from the very important work you're doing, is that we see still there are a limited number of narratives. But I would like to underline that we have so many unknowns about the future, and that there are some big impacts, for instance, of the nexus between extreme weather events like droughts, conflicts, and hunger. This is well captured in the recent SOPHI reports, for instance. And how do we capture this in the modeling? How do we know whether we are heading in the right direction through the combination of options? So I'm suggesting that to some extent, we would need to have more than narratives, some stochastic modeling. Stochastic modeling of combination of drivers. So the drivers are partly unknown. For instance, to which extent will we have a westernization of diets or not? We cannot fully answer. And also some stochastic modeling of combinations of responses. In this way, we could develop an envelope, an understanding of the envelope of where to go, what is the space where we can reach the SDG targets. So I must say I've been working a bit on this with a relatively simple model, and we do see that there is a limited space to reach SDG targets. There we try to really embed in the models the targets, so you answer in a quantitative way to some of the targets at least. And indeed, I came to the same conclusion with my colleagues from the IPCC Chapter 6 group, where we were working together on the integration of responses, that you need to bundle the agricultural efficiency responses, the nature-based solutions, and what I would call food sufficiency responses, so changes in diets, reducing food loss and waste. And this bundling is really essential to reach the targets. We must say, however, that even when you reach the SDG targets, say for 2050, you are not going to solve the planetary boundaries. For instance, solving the imbalance in the nitrogen cycle would be far beyond reaching the SDGs. It would be far more demanding. So I think we have to admit we are not yet there for our understanding on how to solve the planetary boundaries issues. Thank you for Camille for what you have shown. I will certainly read the papers about social justice. It was a bit unclear in our group how we could embed this in the modeling. So your guidance would be excellent. The last thing I wanted to say is that in fact we have this huge heterogeneity across world regions and countries. And I would like to ask a question. Do we think that convergence in terms of production systems, convergence in terms of diets, is a plausible hypothesis for reaching the SDG targets for food systems? I think it is an hypothesis, and maybe I would be interested to have your opinion on this. And my last point was about, yes, indeed, do we know where we have sustainable land and food systems? And could we better use, for instance, remote sensing for finding where are those multifunctional land mosaics, to understand where are the healthy and diverse diets? And in fact, we built on those case studies some examples of where to go, and this could be helpful also for the modeling and for the narratives. Thank you.
Thank you, Jean-Francois. I must say I'm so happy that we are recording this session. I mean, this is such a valuable discussion already, you know, so many good points. And Jean-Francois, you brought in more points, you know, conflicts, and certainly we are probably way too optimistic about our scenario setting compared to the real world out there. I also see Monica's comment in the chat. I mean, of course, we can also look at more pessimistic scenarios. I mean, in the IPCC sense, we have, of course, an SSP3 where you have less cooperation, you have more barriers. But given the current reality, I mean, we had a discussion in the IMC consortium to say, well, is our business as usual pathway rather the SSP3 compared to SSP2, right? I mean, the world is knowing it's not going into any sustainable direction, really. So yeah, I think these pathways have several purposes. Before I let Isabelle and Benny reply, one is, of course, to show, yes, it's possible, and it's possible to achieve ambitious goals. I think we can also show what happens if, you know, they're not being achieved. But we could probably, maybe we should look into more pessimistic scenarios, how things could get even worse, you know, if not even the minimum things are implemented. And I think Jean-Francois, you pointed to this aspect of, you know, we need this cross-scale interaction. We need to translate those broad global pathways into what could this mean for a certain region. And also a very interesting point, where are the success stories, right? Where are the places where we can show that things work? And then we can also, in principle, go the way back up, say, what if these solutions would be applied elsewhere or in different places, just to build on the success stories. I think these are all very crucial elements for the discussion. Cool. Before we open up for Q&A for the whole group, I would ask first Isabelle to maybe briefly respond to the points you want to pick up, and then Benny, and then everyone else, please raise your hand virtually, and I will try to keep track of that. Isabelle.
Yeah, first of all, thanks a lot for all the interesting and highly relevant comments. Much appreciated. Regarding the first topic or cluster of topics, it was a lot about kind of location, and I also think that's kind of highly relevant to better understand and integrate in the models where is happening what, and to integrate Earth observation data, but also kind of ecosystem services, and this requires to to go beyond our limits and scope of our current model capacities, and to understand better how the architecture of land use is. And here we try a lot to improve regarding this aspect, also in collaboration with Chess and Johnson, where we couple MACPAI outputs on land use with seals to get a much more highly resoluted output of land use patterns, and to better understand how kind of the spatial homogeneity or heterogeneity also makes an impact, and not only kind of the total of land use, but also kind of where it is located and how the configuration is. And we are only starting now with we have a publication regarding pollination sufficiency already out, but there's so much to know and so much to improve on. But we were not ready to use this within this shape context. But yeah, we see there's a need to further improve. Also, if we want to better understand ecosystem services and also the non-instrumental values of land, that was also much appreciated and also brought up by stakeholders in the shape dialogue, that we need to better get a grip on these things. We try to resolve this via integrating it more in the narratives, but modeling capacities are really limited to say something meaningful regarding these very important aspects. Yeah, but there's pressure to to also improve here, or to collaborate more and cross borders of within collaborations. Regarding the second point, it was also mentioned as a blind spot by the stakeholders, so land grabbing, land tenure, as a very relevant aspect, and that modeling studies kind of tend to leave it out, with very kind of severe effects on some social groups. Again, here capabilities are limited. We also try to especially create the resilient communities narratives within the SHAPE project to at least qualitatively touch upon aspects, so local solutions, secure land tenure, really limits on afforestation, limits on second generation bioenergy. But our tools are also limited here, and I think a way to go would also be to increase exchange with social science or with other methods to improve. Also regarding to make values more explicit. That was also feedback. And again, the solution was to try to embed it more in the narratives, because in the tools are not fit to do so. Yeah, regarding the policy landscapes, also very interesting points and helpful for further develop the work. I also like the idea very much to use stochastic modeling to kind of more understand also the option space. So we tried to increase the option space by going by this 12 dimensions, and in a plug and play mode, kind of modular rebuild up certain narratives. And as I said, it would also be possible to construct more, but it's still kind of constrained, especially these three narratives. We don't really understand what are the kind of the most relevant parts, how relevant are certain interventions, how they combine, and another approach to really kind of populate the option space more and to understand the individual impacts. Also, maybe Benny's study is a better example for this, to really understand what is which intervention is doing what. It's really very important kind of to increase understanding about sustainable futures. And regarding the heterogeneity of regions, I cannot really say if convergence is good or bad, because it's not about my values, which are relevant, but I can also report from the stakeholder dialogue that there were different perspectives of different regions. So we had, for example, a group from Africa, a group from South America, a Europe group, an OS group, and the perspectives on how they liked certain aspects of the three presented narratives, they differed. For example, South America was more interested in certain aspects of the resilient community narratives, while this was not so much kind of the focus of the European stakeholders. And so I would say from this perspective, people would not like to converge to the same. So it's really kind of more the stylized directions and for understanding trade-offs and synergies, but still people would prefer different pathways in the end, I think. Yeah, I think that was it from my side. And yeah, thank you once again.
Yeah, thanks a lot, Isabelle. Very, very nice. As you talked about cooperation, I mean, this is also one way where we could improve, right? From what we heard from Camille, for example, I mean, we could start to use inputs from your approaches on justice and constrain our models, and the other way around, right? I mean, just as one start, just to use outputs from one study and use that for the scenario definition of the other model to at least somehow connect the strengths of the different approaches. That was just an idea I had when I listened to Isabelle. Benny, what do you have to respond to the discussants?
Yeah. First of all, let me say that I really like the format. So this that we have discussants and get structured feedback. That's very cool. I like it. First response to Becky. So you're saying there's more data out there. Yes, but not necessarily useful data. So there's information out there usually. But the problem is that we need a very clear interface for modeling. So first of all, we need global studies, because otherwise we cannot use them.
Sorry, Benny, you're somehow interrupted a bit.
Okay.
Well, keep
Is
trying.
it becoming better? Yeah. Okay, so there's a lot of data out there, but am I still okay, or is it no? Okay. Shall we delay my
or maybe drop your video.
Yeah, maybe you dropped your video. Looks like a weak connection to me.
Maybe give me 5 minutes.
We can take another question in between and get your response later. So I would just open it up right now. don't see any hands up, but please, everyone in the audience, let's take the opportunity while Benny tries to fix his problem. Everyone taken by surprise right now. Tom, go ahead, please.
Becky raised this question about these under-yielding areas. And I think there are programs designed to try to take those out of production with mixed success. The Conservation Reserve Program in the US, for example, at times it surges, it takes a bunch of those lands. It used to be highly erodible lands. Now there are other considerations, but lands that aren't really economic and environmentally beneficial. And by bidding, by having an established, they're not going to pay a fortune for that, so they can only bid in the lower yielding land. But I think there have been times when it's been quite successful, and then the prices go up and the land comes back in. That's been a challenge. But do you have any thoughts on how those programs might be improved, or any comments on that? I mean, it does make a lot of sense from an economic perspective as well.
Oh, Tom, I can't believe you're asking me. I feel like you are such a more of an expert on this topic than me. I think it's just, you know, one thing is that I don't see a lot of spatial prioritization going into very many of those programs, you know. So if we could bring the government, and I don't know how it is in Europe, someone brought up the greening CAP programs. Maybe they're more advanced than we are in terms of accounting for that kind of heterogeneity, but it does feel like there's a lot to be gained through CRP, but also through EQIP and other, you know, programs that are providing these green subsidies in a sort of uniform way, when that's really not how the values, green values or any of the benefits are delivered. So I think that, I don't know, it feels like an uphill battle there, because it's just like trying to reform that machinery can take a lot of time. Certainly taking away some of the perverse subsidies would be a huge part of it too, which I know you've done a lot of work on. So just, you know, balancing those scales. But it just has always felt, you know, as a landscape ecologist, you look at those systems and it just feels crazy that it's like that we are wasting resources so flagrantly.
Maybe, Tom, maybe I can add a bit. I mean, this is a very interesting question, right? I mean, we increasingly know more about the spatial heterogeneity and how things would need to be done more, also the programs, right? More spatially explicit and then maybe even flexible over time. Maybe one example is like this peatland re-wetting program. So there's now a big program in Germany because, well, peatlands in Germany, it's like something like 5% of the cropland area. 5% of the cropland area create 5 to 6% of total greenhouse gas emissions in Germany. Can you imagine? A tiny area, highly concentrated though in parts of the country, but really creating a lot of impact on greenhouse gas emissions. And now there is a big program targeting, you know, re-wetting programs. But can you imagine? I mean, this hasn't barely started. And, you know, how to organize this at the regional level, you need cooperation between all the agents and so on. And this would apply, I guess, Becky, right, to any other program on whatever, maximizing pollination, or you talked about this, or someone talked about this water retaining in the landscape and this kind of regional feedback on what, I mean, this complexity to design those programs are, of course, stunning. And then you put that into the context of, there was one comment by Monica in the chat on, you know, what's the current discussion on the further reform of the common agricultural policy in Europe? You know, this is so far apart. It's really hard to see how this can really move forward. But okay, we have to be hopeful and provide some examples how it can work. But very, very interesting. Cool.
Benny's back.
Yeah, like, is it now all good? Can you hear me?
Yeah, we can hear you. Get going.
Okay. So response to Becky. Yes, in principle, there's a lot of data out there, but it's not really that we can use much of it because it's often not global, because it's often not harmonized to official databases, and because it's sometimes also not thought of in the way that modelers would afterwards need it to be used. For example, taking moisture recycling, I'm not sure. Probably, maybe there's a new data set out there that is great. But what we would require, for example, would be something like a source receptor matrix, where we see for each point on the world, if you evaporate some water there, where does it come down again? And we would have a big matrix. In principle possible. I heard it from atmospheric transport modelers, but super highly computational intensive. So nobody is doing it. But it would be super useful if you had that, and we could put that in. And for many other data sets, I think it's the same. So there's a lot of data out there, but we can only use it as modelers as soon as it's global and harmonized. Second answer to Camille. Yeah, I see the point, and I think it's a very big risk as well that we, for example, assume perfect institutions often in the scenarios. So we are thinking, okay, we are including a CO2 price, and the CO2 price is implemented everywhere, and then of course there's no illegal deforestation because by assumption institutions work, and that's often not the case. And we are also looking at institutions very much in a Western way. So basically thinking of political institutions where, I don't know, the most efficient or best working instruments are taxes and so on. In some countries, you can't implement a tax because you don't have the institutions in place that can efficiently get them in or something like that. So I think not only for the modeling, but also for the scenario design, this can be helpful. And I think, for example, measures that reduce the pressure, like food demand measures, avoid leakage effects into other world regions, and therefore are probably much better. And we probably should also think about border adjustment and similar things, where we basically contain to some degree any transformation within regions that are similar, kind of. So if you're thinking of trade zones or something like that, that you make sure that you only include partners which, for example, have deforestation stops in place or similar things. And the last comment with regards to efficiency, I don't think efficiency is something negative, and I don't think it's in contrast to other things like sufficiency. For me, in both sufficiency, efficiency, and this is something that I always try to promote. These are not two alternative concepts, but often you can combine both. A comment to Jean-Francois. So you asked at the end, convergence, is it, or what, whether we expect convergence or whether convergence is a good thing? First, I would say there are two big dynamics that lead to convergence at the moment. One are markets, and we see, for example, the nutrition transition that happens all around the world brings people to eat very similar things. And to some degree, this is because those products are very good and very marketable. That's one process that leads, in my opinion, to a convergence. A second process is policy. So you would usually always try to get rid of negative things. What I said already before with the envelope, right? So if, I don't know, people eat too much processed foods, then you will try to reduce processed foods, which means you get a convergence in the sense that you would only regulate if people eat too much, but you would not start to regulate if people eat very little or something like that. So you usually constrain things, and thereby I think you automatically get some type of convergence. Now, the other thing is what processes would actually increase diversity, and this is not so clear to me, but it's a good point to think about. I will take it. Yeah, thank you.
Yeah, thanks, Benny. Your voice was still a bit distorted. I don't know what's going on, but I think we got most of it, so that's fine. Yeah, are there more questions? I guess we would have time for probably one or two questions. I see Sasha put in the chat, maybe feeding in some of the results into the Arias platform. Maybe you want to add a bit to that, but okay, I see Tom responding. And then we have Carter. You have to raise your hand, please.
Yeah, hi everybody. As those who know me, I'm a practitioner, not a researcher, and I applaud the research and the modeling and the scenarios and detailed analysis of trade-offs. This is exactly what we need. So my comment has more to do with the policy uptake. So maybe for Jean-Francois, I do think of the dialogue on these topics, sort of supply and demand. And this seminar has been very much on the knowledge supply side. So I'm curious how to increase the demand side for this information, for the recommendations, not wanting to be too simplistic. I do think that indicators really help, particularly of trends. I think benchmarking really helps, comparing across countries, because countries really do, and governments really do look across and try to learn from each other. And in a way, in the forums that I attend, often governments listen to other governments more than they listen to researchers and academics. So I'm just curious, on the demand side, how do we increase the uptake of lessons that are complicated, nuanced? How much do we simplify? How much do we unify, solidarity, et cetera, sort of things to increase not only the uptake, but the the prioritization, the sort of the importance of what this is. Thanks.
Yeah, thanks, Carter. And we are also approaching the end of our seminar, so I suggest we take Maxwell's point as well, and then I give it to Jean-Francois, and then we start to wrap it up. So thanks, Carter. And Maxwell, you want to add your point?
Yeah, sure. Thank you. And I want to thank all the speakers. This was a really interesting conversation, and the presentations were, I look forward to following up on all of your research. So I'm a PhD student, a lowly PhD student at the Integrated Earth Systems Dynamics group in McGill University, and I was struck by some conversation about a need for greater geospatial detail, as well as I think Jean-Francois, you mentioned wrapping IAMs a little bit more with some demand side detail, for example, with diets. So I've spent the last few years studying the global food system kind of at the geospatial grid level, and using FAO food balance sheets to know how much each grid cell is producing and consuming. And I just wonder, work like this geospatial detail and demand side detail, how best can this supplement existing integrated assessment models? Because from what I've looked at, I'm often confused at like entry points from the outside, because they seem very complicated to me, and I don't have a strong economic background. I'm more of a mathematician. So again, thank you so much to everyone, and I really appreciate it.
Yeah, thanks very much, Maxwell. Jean-Francois, you were pointed at a few times, so maybe you want to respond, and then if anyone else from the speakers, please raise your hand, and then we wrap it up.
Yes, thank you, Hermann, and I'm not quite sure I can really respond, but just I wanted to say that for Maxwell, I think the geospatial here again could provide very interesting case studies, because that could be inspiring, for how we can move towards better futures. So that's maybe one comment. And actually, what you did with the diets if we could plug in, for instance, ecosystem services, some justice dimensions in some sort of geospatial understanding, and define interesting case studies, this could be taken to the policy level in the food system, summit and the stock takes that will happen in 2 years. I think we need such things. We need positive narratives of where to go, even if they are relatively local. It can be very useful. And so the big question about the policy making, as we can see it, and we see this in this process follow-up of the Food System Summit, is that you need to have some cross-ministry coordination, and that's not happening, in fact. So the food system pathways, they are mostly driven by the agriculture ministries or ministers. And what we realize is that you would need at least to have a dialogue with the health ministers, with the environment and climate, ministers for climate and so on. So you need really coordination of policies across several dimensions. And this is agriculture, food, health, climate, at least. So this is where, and quite presumably finance and budget, because that's also what is ultimately creating the possibilities for governments. So how do you do this? It's a very big question. In each country, it's a very big question. And maybe I can speak for France because I'm also in a national committee for the French government, our climate change committee. We have been asking for this. We have been asking for climate change to be taken to the Prime Ministry office. And in fact, this happened, I guess, for many other reasons. But I think this sort, what now we have is that we have planning for climate change, we have planning for ecology, and to some extent, it is helping a bit the policy making. So here again, trying to read that dialogue, that coordination across ministries is a key component. Thank you.
Yeah, thanks, Jean-Francois. Those are very good points. I want to throw in one more example to respond to Carter. I think we're not quite there yet, but I think we're getting there, that the demand is also increasing. Take Europe, we have now effective climate laws in place, net zero targets by mid-century or 2045. Now the discussion about forest carbon sinks, for example, is it's almost faster than the science can follow. So all of a sudden, the policymakers realize, the forest carbon sinks may be either not that stable or they may not be as large as we have planned. Then immediately you have an interaction in principle to the agricultural sector. So I expect with the increasing stringency of the climate targets, that more demand will come to assess different options. How can we actually solve this problem? Because very quickly in Europe, they will realize we'll not get down quickly enough with the agricultural emissions, by far not. We are not, the carbon sinks are probably overestimated. So what do you do then? And then, so I think it's slowly coming, but we are not quite there yet. So that's what I would like to say. Anything from Isabelle or Benny or Becky or Camille to respond? Otherwise, I would hand it over to Tom to wrap up. Don't see any hands. Tom, over to you. And thank you very much to all the speakers and discussants and everyone. Very nice seminar. Thank you from my side. Thanks for coming.
Yeah, that was terrific. Thank you, Hermann, for chairing and having the kind of conceiving of this session. And thanks to all who participated, presenters, panelists. I know you put in a lot of time. You're all very busy, but I think this was very fruitful. Holly has posted information about where you'll be able to find the recording of this. So that'll be important. Please do join the listserv if you aren't on it already. That's the way you can keep up on future workshops. Keep in mind for the young folks out there, there are opportunities to support your travel to visit some of these esteemed individuals and their research centers and gain some more experience. So go forth, do great work. These are such important problems. Thank you for participating, and we'll see you at the next workshop.